So first off, an element with a mass 750 grams decays by 18% per minute. How much of the element is remaining after 13 minutes to the nearest tenth of a gram? So since we're looking at some kind of percentage here, we're expecting this problem to be a percent of change problem. Now, since we're looking at a percent of change, we need to take the original or starting value, which it says right here, an element with mass 570 grams. That tells us that we'll start with 570 grams, which means it's the original value, 570 grams right there. Now, applied to this original value is a percent of change, and the percent of change, we always start with 1 because that represents 100%, and we have that 100% there because you always start with 100% of whatever you start with. Then it says up here that 570 grams, it will decay. Now this is the actual change in the percentage because it's telling us it's changing in decay, which means it's going to be subtracted from that 100%. Okay, so you start with 100%, you take away some percentage of change, which it says already that 18%. 18%, if we were to change this into a decimal, we would move the decimal 2 times to the left, or you can divide it by 100. It doesn't matter. The same answer, you'll get the same answer there as a decimal, 0.18. Okay, so as a decimal, you start with 1, which you could write as 1.00, but then we take away 0.18. Okay, that's 18%. Okay, so the change is 18%. Now, what we saw from the last lesson is you could start with 1 minus 0.18, right? And then whatever this change is, you can apply to the 570. But this, if I only show this one time, that's only for 1 of the minutes because it said it's decaying 18% per minute. We got to do this 13 minutes. Now, I don't want to do the repeated multiplication on this one, and I kind of assume you don't either. But my 13 minutes, what I can do, since I would just be repeatedly multiplying by the 13, is I can just say, well, that percent of change, let's just raise it to the power of 13. Okay, so that's why it's an exponential equation. It's because it's repeatedly being multiplied by this percentage, whatever it is. Now at this point, I take my calculator and so in my calculator, I got 570 parentheses 1 minus 0.18 close parentheses to the power of 13, enter. My calculator says I get this number. Okay, so that's how many grams this would be after 13 minutes of an 18% decay, starting with 570 grams. It's not very much left, and it's still decaying, by the way. But it said, round this to the nearest tenth of a gram. Well, the 1 is in the tenths place value. Immediately to the right of the 1 is a 9. And since it's 5 or more, in the hundredths place value, I have to add 1 to the tenths place value, which makes that 2, 3, and 4. 43.2, we'll label it in grams. That's it right there. Here's our objective for the day. I can graph exponential equations. Take 30 seconds, write this down, then we'll get started. When we graph exponential equations, the x will be in the exponent. Okay, so what we need to do is choose easy values of x. So I'm saying this because for this particular lesson, in the past, what they did is they gave us a table or a graph, and then we figured out the equation. For today, we're going to have the equation, and from there we make a table and graph. But the table is kind of the key part of this because we're going to have to make the table ourselves in x and y, right? So the table is nice because it gives us ordered pairs, and that's crucial for us. These ordered pairs are values which make the equation true, which we'll talk about as well. On the assignment today for Canvas, you'll need at least 4 points, 4 ordered pairs to put on the graph, and then it will let you actually draw the line. So we need to be putting those points on the graph as we go, and then once we have at least 4 of them, then we should be able to draw that graph, okay? But the table is crucial because, again, these are ordered pairs. Once we have those ordered pairs, then when we look at the graph, we can put them wherever they need to go on the graph, right? So if you had like 0, 1, maybe that goes here, and then 1, 2, and then 2, 4, and something like that. And then you kind of see that pattern on the graph. But this takes us back to both Unit 1 and Unit 2, where we were solving equations and then graphing them. But when we were doing the graphing in Unit 2, these were straight lines. Now we're looking at curved lines because we're looking at exponential equations. What we need to remember is that a solution is a value that we can replace a letter with that makes the equal sign a true statement, right? So let's say, for example, that you start with y equals x plus 1. Okay? Now what we have to do, like we saw on that last slide, is we have to choose our own values of x and find the corresponding y values. That gives us ordered pairs. But we have to choose them, okay? So in the past, maybe they've given you these x values, then you find the corresponding y values. Now we have to be adults about this and actually figure out what y values or what x values we will choose. Now, on the last slide, we also saw we want to choose nice x values. So even if it was linear like the equation we're seeing, you'd want to choose a value like x is 0. Why is that? Because putting that into the equation here really isn't that bad, right? You'd get 0 plus 1, and 0 plus 1 is 1, which means that when you replace the x with 0, you get a y value that is 1. That's the y value that in the ordered pair right there. 0, 1, and then from there you can put this ordered pair on the graph. But again, you're going to have to choose your own x values, right? So you could say 1. 1's easy to work with. Then you'd have 1 plus 1, which makes the y value 2. This, again, is an ordered pair. It's an ordered pair on the graph because it makes the equation true. Okay, and then you could see other values like 2, 3, and 3, 4. Maybe you went backwards in the table. You did negative 1, 0. Okay, so all these ordered pairs that I'm showing right here would make this equation a true statement. So in Unit 1, when we were solving equations, we only found one value that would make the equation true. We did see some examples that had infinite solutions and no solutions as well, but for the most part, we had one solution. Now, since we're dealing with 2 or more variables like we did in Unit 2, we expect to see many different values, many different ordered pairs to use in order to find the ordered pairs that will make the graph. Okay, because once we have these ordered pairs, we put them on the graph, and we're good. The good news for us, too, is that a graph is a nice way to show that there are an infinite number of pairs that would make the equation true. So any value between these 2 ordered pairs, for example, there's an infinite number of those because you get as many decimals as you want. The point of this whole slide right here is that we are creating our own solutions. Okay, we're forcing the equation to be true, but we have to choose an x value first. So let's start with this one. So in this one, I've got my equation, 2 to the power of x plus 3. So I've got myself a nice table here, and I'm going to give myself plenty of opportunity to find ordered pairs right here. And could that take a long time? Maybe, but I'm going to let the calculator do a lot of that work for me. So let's get started then. Now, like I said, I like to choose an x value. I really just like to start with 0 because 0 is a very easy number to work with. So in this, then, we would have 2 to the power of x plus 3. But instead of using the x, I'm replacing the x with 0 because I'm choosing that x value, 0 plus 3. Okay, and this will be my y value. Now, if you did this by order of operations, you'd get 2 to the power of 3, which is 2 times 2 times 2, which is 8. Now, I did a little bit of extra work here. I won't do that in the future because this is something that I can put into the calculator. And I get this ordered pair, 0, 8. Let's put this on the graph. 0, 8, I found it. So x is 0, the y value is 8. There it is. Now, it'd be nice if we could graph one point and be done, but we have to get many points here. So I'm just going to work my way up. So I'm going to choose an x value that's 1. Do you have to choose x as 1? No, you can choose whatever x value you want. But I would recommend staying within the parameters of the graph. So I wouldn't go beyond to the left of negative 10, and I wouldn't go to the right of positive 10. I want some values that should fit on the graph at least. Okay, so then my equation becomes y equals, it's base 2 to the power of not x, but 1, and then plus 3. Again, I can put this into the calculator, and I get 16. So 116 is nice. It's just, it doesn't fit on my graph either because it's too far up. It'd be somewhere up here. I can't fit that on my graph, so if I were to go further down, let's say I did 2, I'm going to skip the work here, but you'd get 32 on that. See, and that's already, again, 16 was too big. If we keep going up here with our x values, we're just going to get bigger and bigger values. So going upwards isn't going to help us with the graph. I've got to go backwards in my x values. So let's try x is -1 here. Okay, I'm just going to go one back. If x is -1, then my y would equal 2 to the power of -1, because I'm replacing that with the x, plus 3. So put this in the calculator and you will get 4. That's my ordered pair, -1, 4. This one does fit. So my x is -1, my y is 4. I know where this goes, -1, 4, boom, there it is. So like I said, on the assignment, you're going to need at least 4 points before you start actually drawing the graph. So let's give ourselves more points here. So let's go to -2. So then y would equal 2 to the power of -2 plus 3. And I'm just replacing that x with -2. But when I put this in the calculator, I get 2. So -2, 2, ordered pair. X is -2. Y is 2. I get this ordered pair. -2, 2. But I can keep going here. Let's see what happens when I make x a -3. Well, that would be y equals 2 to the power of -3 plus 3. Now, for those of you that are familiar with this is -3 plus 3 in my exponent, which would give me 2 to the power of 0, and anything to the power of 0 is 1. So I get this ordered pair at -3, 1. So x is -3, y is 1. This point right here, -3, 1. Now this is enough to graph the line, but you have to understand what's happening to even to the left of that point that I put on there. So what I'm going to need to do is I'm going to actually need to continue expanding the table. I'm just going to use these spaces down here. In fact, maybe I will go. So if I said x was -4, then your y value would be 2 to the power of -4 plus 3. If you put that in the calculator, you get 0.5. Now, here's the problem with 0.5 is on the assignment, on Canvas, it won't let you put in these half points like this. So even that point that I just put on the graph is going to make the equation true. I can't put it there. So here's what I'm going to do. I'm going to go all the way to -10. Again, I'm skipping some values. And I put in my calculator y equals 2 to the power of -10 plus 3. And then I'm gonna see what this gives me. So in my calculator, base 2 to the power of -10 plus 3, enter, and it gives me this decimal value, 0.0078125. This value right here is close enough to 0 that I can just say, yeah, you know what, it's pretty much 0. Now, why is that? Because 7 thousandths on a graph this small right here, over here, I don't even know where that goes, right? It's so close to 0, it may as well be 0, is what it's saying. So that'd be -10, and then pretty much 0 right there. Now, I'm purposely still offsetting it off the line because I know it's not quite 0, but I can see the pattern now. It gives us a nice curve right there. So on the assignment, once you put at least 4 points on the graph, then up here at the top, it's going to say done plotting points. You click on that, and once you click on it, then you can draw the line. You're going to have to do this with your mouse, so you're going to have to be careful, okay? Now, I recommend doing this a little bit at a time. So here's my attempt at it. But I recommend doing it a little bit at a time so that you can undo certain parts of it. Okay, so this one, again, I'm kind of stopping there. Then I continue to the left. I'm trying to stay off that x-axis. And what I have to do is once you draw the line, you have to make sure that it goes all the way outside the graph in both directions. So here on the left, I got to make sure this arrow's here. If you draw the line yourself, it'll put the arrow right there, but it won't accept it unless you drag it all the way out. So there's that. Now I've got to do this upwards as well. So let's see if we can get this on there. All right, here we go. We got just a little bits at a time, something like that. And then I got to extend this up like this. And again, once I get up there to the top, it should show me an arrow. And this is good enough for me right here. Now, is it good enough for the computer? It's hard to say. What you can't have is you can't come too far away from where this line should be, but it'll accept something that's pretty close to it. Okay. Now, is this going to take some time on the assignment? You may have to do and redo some of those. It may say it's incorrect, but your graph is pretty close. In your mind, if that's the case, just understand you're doing it right. That's the main thing. But the computer may not accept it unless it's a little bit more perfect. Okay, and yeah, it's a little bit easier to do this by hand, but we're doing this on the computer. So you have to make sure that you get the table. Okay, you have to get the ordered pairs. You get your ordered pairs, put those on the graph. That gives you enough pattern to draw the line. That's what you need. So here's a word. There's a math word, asymptote, which is kind of a weird word. I wouldn't, try to use this word so often outside of math because people probably wouldn't like it. But here in math, if you say the word asymptote and there's a bunch of math nerds around, they would rejoice because now they feel like they can talk about asymptotes. But an asymptote is a line on a graph where the line that you're graphing, it may get really close to that line, but never actually gets to it or crosses over it. Okay, so that's what an asymptote is. In the equation, it's just a value that's being added or subtracted, like this one right here. Okay, so this one, of course, it could be subtraction, which would make it negative. But in this format, this becomes our asymptote right there, C. So what it says right here is that it's a horizontal line. Our asymptote is a horizontal line. And we know from horizontal lines from the last unit is that it will take the equation y equals whatever this value is. Okay, it's just y equals some number, and then that creates a horizontal line. I'll demonstrate this with the last example that we just did, but first it says this is the equation that we just barely did in the last example, but it says y equals 2 to the power of x plus 3. What is the asymptote, or where would be the asymptote for this one? There's just a phantom plus 0 right here. So the asymptote would be the equation y equals 0, which again, that's going to give us a horizontal line. So this is the graph that we drew for this equation. Now it wasn't showing the plus 0, it's a phantom plus 0, but it was there, just couldn't see it. But this gives us this line right here. It's right directly on the x-axis because, and this, I could have drawn this better, but this line will never actually get to the x-axis, meaning the value of it will never actually be 0. We saw over here with negative 10, it's something very close to 0, but not quite there. And that's on purpose because we had on the graph, even though we couldn't see it, but now we can, this is our asymptote. By the way, there's no spelling tests on this, so we're never going to ask you to spell this on your own, but we need you to know what it is because we're gonna be seeing them now. Let's graph this function. Now, in relationship to the slide we just saw, I have an asymptote right here. It's showing plus 3. So our asymptote would be the equation y equals 3. So on my graph right now, y equals 3. So on my y-axis right here, I find 3. There it is. I get a horizontal line right there. So let's get that on the graph. There it is. Now this means that wherever the graph is, it can't cross this line. Meaning if it's this way, it can't cross the line. It can't cross this line here. Even if it's below, it doesn't matter. It can never cross this asymptote right here. So now that I got my asymptote, hopefully we understand what it is. But let's figure out where this graph is. So let's put it in a table right here for us. And we're going to choose our own x values. So like I said, I'm going to give myself some space just in case I need to go into the negatives. But I'll still start at 0. So I'm saying x is 0. Now again, we're just going to use the calculator right here, but y would then equal 1/2, which I would need to put in parentheses before I push the exponent button. Now it's x minus 2 is my exponent, but I've chosen an x that's 0, so it's really 0 minus 2, and then we can add 3 to that. So if I put this into the calculator, so again, you're going to need parentheses around your 1/2 to the power of 0 minus 2 plus 3. I get 7. So this is an ordered pair, 0, 7, right? And I can go to my graph now. X is 0, y is 7. That's my y-intercept. 0.07. But I'm going to need some other points. So let's try the next value. We'll say just 1. And so the equation would be y equals 1/2 base to the power of 1 minus 2, and then plus 3. When you put this in the calculator, you will get 5. So that tells me that I get the ordered pair of 1, 5, which for me, 1, 5 is right here. So on the computer, right, we're going to need at least 4 values. Let's see what happens when we put 2 in. So that would be y equals 1/2 to the power of 2 minus 2 now, but plus 3. And from here, this will be 4. Okay, just put that in the calculator. You should get 4. That's 2, 4. So my x is 2, my y is 4. There it is. 2, 4. So you see how we're getting really close to this asymptote as we go to the right? That means that my next value is probably going to be some kind of partial value, but the farther I go to the right, the closer to positive 3 that I will get. So let's plan on putting a couple more values in here. I'm going to start with 3, just to show that we are expecting some kind of decimal value here. So that's y equals base 1/2 to the power of 3 minus 2, but plus 3. And if you put this in the calculator, you will get 3.5. So 3.5, it'd be 3.5. So I go over here to 3, x is 3, up 3.5. That gives me this halfway point. Now, again, on the computer, it will not accept that halfway point. It will not allow you to put halfway points on there. So I'm gonna take this to the limit on my graph, which is an x value that's 10. Okay, so I'm saying x is 10. That'd be y equals base 1/2 to the power of 10 minus 2, but plus 3, equals. Let's see what happens when we do that. If I put 10 in there, I get 3.0039, which is pretty close to 3, right? In fact, rounding, you could even make this 3.00. So 10, 3, I'm going to put it just above 3. So 10, 3, again, I'm going to get really close to that asymptote, but not quite on it. So I'm going to put this point right here. I'm not labeling it because I do get a decimal value, but this is my point right there. So I'm seeing that curve, right? But let's go back and see what happens if I put -1 in here. It should be somewhere up in this area. So let's put it in there, -1. So I've got -111. Now that's, for my graph, since I'm doing it by hand, I could kind of draw it right there. But in my mind, if I was doing this on the computer, I can't put that point on the graph. This is enough though. Okay, so I have 1, 2, 3. Again, I can't put this one on there. I can put this one on there, but this gives me a nice curve that I can draw. So on the assignment, again, you'd push done plotting points, and then it will allow you to actually draw the line. So again, take your time doing this. Be very careful, otherwise it's going to mark it incorrect. So I'm just going to kind of go from one point to another. See if I can do this decent. Now again, I'm trying to stay away from that orange line, the asymptote, because it shouldn't touch or cross it. Okay, so I've drawn this line, which you can still do on the assignment. You can go one way and then go the other way. But I need to go pretty much straight up at this point, almost. But I got to get in my mind where that red point would be. So on the computer, again, you've got to make sure that you get the arrow on the outside of the graph on both sides. So make sure you extend these in both directions. If you don't see the arrow, it's going to mark it wrong automatically, no matter how nice your drawing is. But this is good enough right here. Okay, and that's our graph. Now the truth is, if I wanted to, I could extend this graph too, right? So my graph, it goes all the way to 10 to the right. If I wanted to, and I'm just going to put this in the table, if I wanted to say, well, look, what happens if x is -10? Well, then I could put it in the equation, y equals 1/2 to the power of -10 minus 2 plus 3. My calculator, it gives me 4,099, which is, again, this number is so big, it's hard to even demonstrate the magnitude of how far up that is from this. But this number right here, so we know it's 4,099. As we make x more negative, it will continue to make this y value more positive. Now, the reason that is because a negative exponent, like you would get here, flips that fraction. So then you would have 2 to the power of 12 in this case, which is humongous, right? And then you still have to add the 3, getting the 4,099. Y equals base 1/3 to the power of x plus 1. You guys try this one out. Take a minute, try it out, then we'll go over it. Okay, so we got a base 1/3, right? No problem. We can still make a table from this. And I'm still going to let the calculator do all the work for me, right? So again, I'm giving myself plenty of space in my table. Let's choose an x value that's 0 here. Again, 0 is nice because it's a very easy number to work with. So we get y equals 1/3 to the power of, that's going to be 0 plus 1, which really is just 1/3 to the power of 1. So in the calculator, you should get 0.3. Repeating, but since I can't get to the hundredths on my graph, I'm just going to put the tenths. So 0.0 and 0.3 is my ordered pair. 0, 0.3, it's pretty close to this x-axis right there. Okay, that's about my y-intercept. Now, if you go upwards on this, okay, which we talked about, so if you say x is 1, then you get y equals, it's 1/3 to the power of 1 plus 1, which on my calculator, it shows 0.1 repeating. Again, I can't get to the hundredths on my graph, so I'm just going to keep this as 0.1. Now, why is this is getting really close to 0, right? So 0, 1, and 0.1 right there. Like if you put 2 in, now I'm going to skip the work on this, but you're going to get 0.0 rounded would be 4. If you put 3 in, you're going to get 0.01. If you put 4 in, you're going to get 0.04. Okay, so these numbers, right, they're getting really close to 0. But why is that? It's because we have that asymptote. Again, it was there the whole time. You just couldn't see it. It's that plus 0 part right there. Asymptote. So that's the line y equals 0. And on my graph, I can put that down, right? So I can say, look, my graph here, x equals 0. Boom, there it is. So I can tell as I go to the right, it's getting really, really close to 0. But it should never touch or cross that asymptote. Now let's go backwards though. So if I were to make, let's say I made x -1, then again, just I'm skipping the work there, but I get 1. So -1, 1 gives me this point. I can do a better point than that. There we go, -1, 1. And if I do -2 for my x, I get a y value that's 3. So again, that's an ordered pair that makes the equation true. -2, 3, this point. And we can fit one more there. -3 and 9. Yeah, so that's already at the edge of our graph pretty much, right? -3, 9. It's right here. Now this, again, it should be good enough to see this pattern, but as long as I know where my asymptote is. So let's see if we can graph this. Again, on the assignment, once you get 4 points on the graph, then you can push done plotting points. So I'm just going to, oh, that's not too bad for me. I know some people would say that's really crappy, but it's not too bad. So let's, again, you got to go all the way to the right. Make sure you get an arrow there and up here as well. If you don't have the arrows on the assignment, it will mark them incorrect. Our equation y equals 3 to the power of x minus 3 minus 1. And that minus 1 right there, boom, that's my asymptote, which would be the equation y equals -1. So on my y number line where I see -1, that's my horizontal line, the asymptote. Let's get that on the graph right now, see if we can, good, there it is. So again, I'm putting this on the graph just to make sure that I know where I shouldn't cross or touch, right? But at this point, what I need is a table. Now here's what I'm going to do. I'm still going to use the calculator to make my table, but what I don't want is to actually have to just keep typing this in over and over and over. This strategy we've talked about before. This is just using the calculator, you guys. So here's what you're going to do. So our button progression on this one. We got to access the table function, but first we got to put in the equation that we have, right? So in the very top left of the calculator, you're going to see the y equals button. Once you push that, there may be something in the calculator from either the previous student or maybe you put it there. Clear it out. So push clear, just so you have a brand new equation. Then you're going to push 3. That's your base. Now we see that we got to get to the exponent, right? For the x minus 3. We're going to push the exponent button. It's one button above the divide button. It looks like this. It's called a caret. You can call it an arrow if you'd like. I don't care. But that's the exponent button. Now we're going to type the actual exponent in. And on your calculator, what you'll see is 3. And then with the exponent button, you're going to see the cursor right there. It's saying, please type in the exponent for me. So we're going to push the X button, which is one button to the right of the alpha button. It says X, and also says T, theta, and N, whatever. But once that happens, then you'll see in your exponent, X, and then you push -1. So you're going to push the minus button, not the negative button, -1. Now we've got to get out of the exponent function, so we're gonna have to push the arrow to the right. From the top right, the cursor is there. And then you'll see that the cursor now is down in the bottom. Then you're just gonna type in -1. Yeah, what did I put? -1, yeah, we need to put thank you. Let's fix that. Push the correct buttons. -3 there. And then -1, there's our -1. So there, from there, then you push -1. Now push enter. Okay, so when you push enter, it's going to go down to y2. So this is showing as y1 equals this. What you're going to do now to access the table is push in the top left. You see this blue button? It says second. And then you're going to go to the table, but to access the table, you got to push graph, which is the very top right button. You'll see right above graph, it says in blue, table. That's what we're trying to access here. Now when I do that, my table's starting at -2, so it's showing a -2 and then a -0.995, I guess. Not that that matters because I can't get to the hundredths, right? Or -1 and -0.98. Then I got 0 and -0.963, 1 and -0.88, 2 and -0.66, 3, 0. So there's a nice one I can put on the graph. 4, 2. Now I've got to scroll down on my table so I can see more values. When I do, it's showing 5, 8, and then 626. I can't fit that 626 on my graph, so I'm just going to graph what I have here. So let's start with the 3, 0. Right there, that's my ordered pair for the x-intercept, 3, 0 there. Then I can put in 4, 2. So there's 4, 2. 5, 8, which is up here. And then again, 626 won't work. Now you see as we go up the table, this is getting really, really close to -1. That's on purpose because of our asymptote, right? So I'm expecting something over here really close to -1 on the left. But now that I've got this, I can graph the line. So let's see if Mr. Sal can not screw this up too bad. So something like this one.
You're not writing with the right hand anyway.
This is my good hand, man. And then we'll take this to the left. I went a little off there, see? Be careful. It's not my greatest, but it's not my worst either. If you wanted to see the graph, which you could do, all you would push right now, without pushing anything else, you just push the graph button. When you do, it should draw this graph for you. You can see as it draws, it's going from left to right. It's drawing this line pretty close to -1, and then it just curves straight up there. There's our objective again. I can graph exponential equations. That last problem allows you to just use the calculator to graph these, you guys.